This unit is given by French scientist Andre Marie Ampere. French scientist Andre Marie Ampere. Next is, what is electric circuit? What is electric circuit? A continuous and closed path. A continuous and closed path of an electric current is called electric circuit. Here we will draw the schematic diagram of electric circuit and show its all the components. Let us suppose this is a conductor or any metallic wire. From this and this, we will apply voltage across the conductor. This is the direction of current. This is your voltmeter, which measures which instrument which used to measure the volt, a potential difference across the ends of the conductor, which this is ammeter, which is instrument which is used to measure the electric current. It is always connected in series. This instrument is always connected in series, and this instrument potential difference is always connected in parallel. This is your battery. This is your switch. Okay, and this is the direction of current is always from positive to the negative terminal of the battery. This is the flow of direction of current, that is from positive to negative terminal of the battery. It is always opposite to the direction of electron. As electrons moves from negative to positive, electrons moves from negative to positive, okay, and electric current is moves from positive to negative. That is the direction of electrons is opposite to the direction of current. Okay, beta. Next is electric potential. Electric potential and potential difference. Electric potential and potential difference, it is represented by short form we can read PD, potential difference represented by V. It is the W by Q, that is work done upon charge. Okay, it is defined as the amount of work done to move a unit charge from one point to another point. As we see in here, is the moment of charge, the work done amount to move a charge of one unit from one point to another point. This is, suppose this is X point, this is Y. And the SI unit of potential difference, SI unit of potential difference. For this we have to know about the unit of work done and charge. Work done is joule, charge is coulomb. That is V is equal to joule per coulomb, which is collectively known as volt. Therefore potential difference as we notice volt, who gave this Alessandro Volta, the name scientist here, who gave the unit of potential difference, that is volt. Next question is arises 1 volt, define. So what is 1 volt? So we apply all this here, that is 1 volt 1 joule upon 1 coulomb. 1 volt is that potential difference between 2 points in a conductor when a 1 joule of work is done. 1 joule of work is done to move a charge of 1 coulomb from one point to another point. I am repeating again, 1 volt is that potential difference between 2 points in a current carrying conductor when a 1 joule of work, 1 joule is the unit of work, okay beta, when 1 joule of work is done to move a charge of 1 coulomb from one point to another point, okay beta. I have already mentioned in the backlist that this is the instrument, which is a voltmeter, which is used to measure volt, a potential difference across the electric circuit, and it is always connected in parallel. And this instrument is ammeter, which is always connected in series. Next is your most important topic, Ohm's law, which shows the relation between potential difference and current, which use the potential difference and current. Examiner can ask you like this: state and prove Ohm's law. So what will you write here? First of all, we write its statement. What statement says? It states that electric current flowing through a conductor or any metallic wire is directly proportional to the potential difference applied across its ends. It states that electric current flowing through a conductor is directly proportional. It's the main point. They're directly proportional to the potential difference applied across its end. We will draw a short diagram for here. This is your conductor, this is your potential difference switch, this is ammeter, positive and negative, this is the direction of current I, okay beta. So what we say that this is the potential difference, this is a volt applied across the ends of the conductor. This create the potential difference. In mathematically we can write it as V is directly proportional to I. This is the sign of directly proportionality. After placing this sign to the equality, we change here R, this R, where R is constant of proportionality called resistance of the conductor. Okay beta, it is known as the resistance of the conductor. So what is this? What is resistance? It is the property resistance. It is the property of a conductor which oppose, or you can say that which resist the flow of charge, through it. From this expression is a very important expression for numerical session. Here we can find out V is equal to IR. We can find out relations like I is equal to V by R, on this, and R is equal to V by I. Okay beta, these three expressions are most important for numerical session. V is equal to IR, this is Ohm's law. From this single formula we can calculate two more formulas, that is I is equal to V by R. I is here, R upon this side, upon divide this V by R. If we calculate R, Y upon this side, R is equal to V by I. Here we know that the SI unit of current is ampere and potential difference is volt. For using these units we can calculate the SI unit of resistance. Therefore SI unit of resistance is, so what is R? V by I. What is the SI unit of potential difference? That is volt. What is current? Ampere, which is collectively known as ohm. Okay beta, that is the SI unit of resistance is ohm and is represented by the symbol this symbol. Remember it, this symbol, ohm. Beta, who discovered it? Sir Simon Ohm. Sir Simon Ohm. Named after the unit, named after this scientist Sir Simon Ohm, who discovered the unit of resistance. Okay beta, understand? This is the symbol of resistance. I show you in numerical session. We show this like this is resistance. You mostly see here in the numerical session. This is the symbol of resistance. There is another symbol same like this, but there is little bit difference. You see this arrow over here. This is known as rheostat. Rheostat. This is the also known as variable resistance. Okay. Rheostat. What is rheostat? A component which is used to regulate current without changing the voltage. Okay beta, a component which is rheostat, a component used to regulate current without changing the voltage is called variable resistance. ठीक है, और किसी भी इलेक्ट्रिक सर्किट के अंदर ये रियोस्टेट जो है वो यूज़ किया जाता है एज ए वेरिएबल रेजिस्टेंस, which is used to change, which regulate the current without changing the voltage. Another topic is factors, on which factors resistance of a conductor depends. किन किन फैक्टर्स के ऊपर किसी भी कंडक्टर का जो रेजिस्टेंस है वो डिपेंड करता है? तो देयर आर 3 फैक्टर्स ऑन विच द रेजिस्टेंस ऑफ ए कंडक्टर डिपेंड्स. Number 1, length of conductor, area of cross section, and third one is nature of material, यानी कि किस मटेरियल का वो कंडक्टर बना हुआ है. एक तो उसकी लेंथ के ऊपर डिपेंड करता है, एक एरिया ऑफ क्रॉस सेक्शन. व्हाट इज एरिया ऑफ क्रॉस सेक्शन? मीन्स हियर दैट this one, this is area of cross section of conductor. This is this area, this one, this is area of cross section. ठीक है, it can be small and it can be big. ठीक है. और what one length of conductor? Length of conductor means this line, this length. And nature of material, which material it is made up of. Okay beta. From this we will find an expression, that is resistance of a conductor. Resistance of a conductor is directly proportional to the length. Resistance of conductor is directly proportional to the length and inversely proportional to the area of cross section. This is your number 1. This is 2. It means that if the length is increased, resistance is also increase. Resistance increase. Okay, it means if area of cross, this is the inversely proportional. Inversely means 1 by. This means inverse 1 by. Resistance inversely proportional to the area of cross section. If this will decrease, so this will increase. If this will increase, this will decrease. On combining these two equations, we get R is directly proportional to L by A. Again here we will remove this proportionality sign and change into equality. Here we use this sign, rho. This is known as rho, RHO, rho. And this is known as the resistivity of the conductor. This is known as the resistivity of the conductor. Okay beta, where rho is the constant of proportionality and also known as the electrical resistivity of the conductor. Okay beta. So here we will find that this SI unit of resistivity from here, this expression, cross multiplying R into A upon L. Because L is on upside, this goes down, and A is here, is upside, cross multiplying. So from here resistance is SI unit of resistance is ohm. What is the area of cross section? Area of cross section, what is area? Is the length and breadth, that is a meter into meter. And what is the length of length? SI unit of length is meter. This is cut down. Okay beta, this is the area. Area is the length. We learn the length of conductor. This is length and breadth. Meter into meter. Here is only use length. Meter cancel. So what is the SI unit of resistivity? Ohm meter. SI unit of conductor is ohm meter. Okay beta, understand? Resistivity is ohm meter. I want to show you something from this expression. This is from this expression we know that resistance is inversely proportional to current. That is R is inversely proportional to 1 by I. This is current, this is resistance. Okay, as we tell you before that this is inverse 1 by. If one quantity is decrease, this will increase, and this will increase, this will decrease. Let it check it out. Let us suppose the current in any wire is 2 एम्पियर, तो व्हाट विल बी द इफेक्ट ऑफ रेजिस्टेंस, तो रेजिस्टेंस कितना हो जाएगा हाफ, करंट इज 2 एम्पियर, तो वी पुट द वैल्यू हेयर, तो रेजिस्टेंस कितना हो गया हाफ. लेट अस सपोज दैट current is 4 ampere, then what will be the resistance 1/4, और कम हो गया. ओके बेटा, अगर मान लो हम करंट को हाफ कर देते हैं 0.5 एम्पियर, समथिंग अबाउट दैट 0.5 एम्पियर, तो व्हाट विल बी द रेजिस्टेंस 1/2 एम्पियर, दिस गोज अप, तो R इज इक्वल टू 2 ओम, रेजिस्टेंस कितना हो गया डबल. ओके बेटा, मतलब रेजिस्टेंस कम होगा तो करंट ज़्यादा फ्लो करके जाएगा, रेजिस्टेंस अगर ज़्यादा होगा तो करंट कम फ्लो करके जाएगा, क्योंकि रेजिस्टेंस की प्रॉपर्टी क्या है, इसने करंट के फ्लो को रोकना है, अपोज करना है, उसको रेजिस्ट करना है. ठीक है, यू विल बेटर अंडरस्टैंड इन दिस सेशन, इन द न्यूमेरिकल सेशन. ओके बेटा, there we will better understand it. After completing the chapter we will do it further. Next topic is most important topic, combination of resistors. There are two combination of resistors. Number one series, second one is parallel. So what is series combination? What is series combination? If all the resistors are joined end to end and same current is flowing through each resistor, then we say that combination of resistors is in series. So I will show you here what is combination of resistors in series. Let us suppose this one. Here we are taking the example of 3 resistors. Let us suppose R1, R2 and R3. This is your battery, this is your switch, this is your ammeter, positive negative. Okay beta, and here across we will apply voltmeter, because this is always connected in parallel. This is the direction of current. As all the resistors are in series, the same current is flowing through each resistor. Same current will flow through each resistor, and voltage is because voltage is applied across, therefore voltage will be different across each resistor. Let us suppose this one, from this one this is V1, this is across V2, across here this is V3. These are different voltages across each resistor. Such combination of resistors are said to be in series. ठीक है, if all the resistors are joined end to end, ठीक है, this end to this end, this end to this end, all the series are joined end to end, so such resistors are said to be in series. Here current will same and voltage is different across each resistor, and current will be same in each resistors. Okay beta. Second one is parallel. Second one is a combination of parallel. But what is in parallel? If all the resistors or not joined end to end, अगर वो सीरिया के साथ नहीं जुड़े होते. But here is current is same, but here is voltage is same. Voltage is same across each resistor. Okay beta, if all the resistors are not joined end to end, okay beta, and voltage is same across each resistors. Here we will draw the diagram for this. You will better understand by this diagram. Look at here beta carefully. This one, 1 2 3, 1 2. This is your battery, this is your switch, this is your emitter. Okay beta, this is your switch, this is your battery, positive negative, here current. Look at beta, look at carefully here. When current is flowing up to here, it is same I, but after entering from this end, current will divide in three parts. That is, this is I1, I2 and I3. This is the resistance R1, R2 and R3. Okay beta, from this end current, when the current is flows through each resistor, it is from this end current will same, but after entering these branches the current will divide. ठीक है, current I1 across R1, I2 cross R2 and I3 cross R3. But when the current, all the leaving, this is the entering current, this is the leaving current, the same current is after this I1, I2, I3. But here is the voltage. Voltage will be same across each because all are in same. ठीक है, voltage across each resistors will same in parallel. ठीक है, in series voltage will different, current will same, but in parallel voltage is same, current will different. This is the difference between two combination of resistors, series and parallel. Okay beta, you have to learn the series combination result. Let us suppose here we taking the examples of three resistors. This is the series combination result RS. ठीक है, combination of resistance series is R1, R2, R3. There can be more RN. Let us suppose RN, and in parallel this is RP, 1 by R1 plus 1 by R2 plus 1 by R3 plus up to 1 by Rn. There are n number of resistance, but in this chapter, your 10th class, they are taking the examples of only three resistors, and by proving these expressions, these are correct expressions of series R1, R2